Hey, welcome back. This is Max Me DC with Debbie, where your hatred for Max turns into love. So, in the previous videos, we were discussing set language. So, we'll continue with that. So, today we shall see the cardinal number of a set. So, let's define what do you mean by a cardinal number of a set. It's nothing but the number of elements inside the set. So, you have to return or you have to say how many number of elements are there in a set. That's it. So, a cardinal number of a set A is denoted by n of A. So, let's clarify this definition with certain examples. So, let's take this set vowels in English alphabet. So, we have A, E, I, O, U as the vowels in the English alphabet. So, the number of elements in this set is 5. So, the cardinality of this set is 5. Note that the cardinality of this particular set or cardinality of any particular set can be easily found when you convert that set to roster form. So, you will see why we have converted each set to roster form in the upcoming examples. So, let's consider the another set x, which is actually equal to the set of all elements x, such that x actually belongs to natural numbers and the boundary of x is from 1 to 3, where 1 is not included. So, since natural number starts from 1, we are supposed to count from 1, 2, 3, 4 infinitely, but there is a restriction where 1 must not be included and x must be less than or equal to 3. So, the elements inside this set is actually 2 and 3, and the number of elements inside this set is 2. So, you got it, the cardinality of this set is 2. Let's consider another example, the set of all even prime numbers. Obviously, 2 is the only number which is actually even and also prime. So putting that as a set gives you just only one element to count. So, the cardinality of this set is 1. Let's consider another example too, where we have to collect the set of all elements x such that x belongs to natural numbers and the boundary for x is 3 and 5 and x and the endpoints are not included. The only elements between 3 and 5 in natural number is 4. So, we have only one element inside this set. So, the cardinality of this set is 1. And coming to this particular symbol is actually called as pi in set language, which actually indicates an empty set or a set which contains no elements. So, a set which contains no elements, of course, it implies the cardinality of that set is 0 because you have no elements to count. Let's consider another example too. So, the set of possible outcomes in the die is actually 1, 2, 3, 4, 5, 6. No other elements can be added or no other elements can be removed, so that we have just only 6 elements to count. So, the cardinality of this set is 6. Moving on to some more examples which we have seen from the previous videos. So, the set of all natural numbers less than 10. So, it's actually 1, 2, 3, 4, 5, 6, 7, 8, 9. 10 must not be included because we have not given less than or equal to. So, 10 must not be included here. So, the number of elements in this set is 9. So, cardinality of this set is 9. Let's consider another example to the set of all positive multiples of 3, which is nothing but 3, 6, 9, 12. Note that you can find any possible multiple of 3 to be included in this set. So, it's actually an infinite set. You can even count up to hundreds, you can even count up to thousands, 10,000s, lakhs, millions, trillions, and to your desired level. So, it's actually infinite set. And let's consider the set of all even numbers before 11. So, before 11 you have 10, which is an even number, and 8 is an even number, 6 is an even number, 4 is an even number, and 2 is an even number, and that's it. You have the set of all even numbers below 11. So, number of elements in this set is 5. So, the cardinality of this set is 5. Let's consider this set of all days in a week, which is Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday. Of course, you have 7 days in a week, so there are 7 elements inside this set. So, the cardinality of this set is 7. Let's consider the set of all integers. So in set of all integers you have natural numbers is 0 and negatives of the natural numbers. We have seen that natural numbers is uncountable, so we have added the negatives of the natural numbers, which actually makes that uncountable too, and we have added 0 to it, so it also makes it uncountable. So set of all integers is an infinite set. So that's all for today's video, and in the next video we'll be discussing these many types of sets. So stay tuned. Tata, bye bye, take care, see you in the next video with types of set.